Okay. All right, so we're gonna do our practice quizzes first. We still have a couple of other practice problems to do back here on this other sheet, and we'll get to those, but I wanna definitely get through the practice quizzes, okay? I also want to share with you information about our second semester paper. How you write paper first semester, we're gonna do that again second semester, right? We're gonna do it right this time. And here's what this paper is about. Today's Ash Wednesday, you know what that means, right? Most of us make some kind of Lenten promise. Sometimes it's giving something up, sometimes, you know, whatever Mrs. Casper was talking about. Here's what I'm asking you to do. And you don't have to be Catholic to do this. I want you to think about some small thing that you can do to improve somebody else's life. So, some examples. Washing the dishes one night a week, or cleaning up after dinner one night a week, or going to the grocery store for your mom. Mom, give me a list, I'll go shopping for you. How about helping a little brother or sister with homework a couple nights a week? How about visiting your aunt or your grandma or somebody on Sunday afternoon? I want you to think about some small thing you can do repeatedly. So this isn't a one-time shot. This isn't, oh, I went to visit grandma, I'm done. This is, I go to visit grandma every Sunday. Or I do something on a regular basis. Not a lot. I'm not asking you to commit hours and hours to it, but just something small that you can do to help someone else. Because I'll tell you, what I get in these papers over and over again is, I started out thinking I was going to help my mom by cleaning up after dinner, but I found out that I really got more out of this than that because I was helping somebody else. So, I want you to think about that. Lunch starts today, papers due March 27th. I'll put everything in Schoology. I don't have the Turnitin codes yet, so I don't have it posted yet, but it will be going in there soon as soon as I get the Turnitin codes. Just like before, you're gonna do this activity, and then you're gonna write. So you can't write the paper tonight. You have to wait until 4 or 5 weeks and then write the paper. How does it impact you? How does it impact the other person? Okay, one page, real simple. No AI. Please don't fabricate. One of the most horrible, not horrible, I guess kind of embarrassing moments was a kid wrote this beautiful paper about what he'd been doing, and it was so touching. I emailed his mom and said, oh my gosh, it was all made up. Yeah. So don't do that. If you really are opposed to doing something for Lent, I don't believe in Lent. Okay, I hope that's not the case, because this really isn't about Lent. It's about doing something for somebody else. But if you're really opposed to it, I'll come up with an alternative assignment for you. But I really hope you'll think about doing something for someone else, small, but doing it on a regular basis, once a week, twice a week. Everybody understand? Okay, it's really kind of a cool thing to do. Okay, all right. So now we got our practice quizzes, and they aren't numbered, but I'll go with the first one in the packet. And this is exactly what your quiz is going to look like, guys. You're going to have a problem that looks like this, and a problem that looks like this. Now, are they going to be these exact two problems? No, but they're going to be these kinds of problems, okay? So, what do we do with this kind of problem? We did a whole bunch of them yesterday. Well, our goal is to cancel things. Do we have any reciprocals in here right away that we can cancel? Yes, if you wanted to, you could cancel the tan and the cotan. I'm not going to do that. You can, absolutely, 100%. you can do that. But I think some of you are getting confused, so those of you that are confused, let's just change everything into its fraction form. Now, by this stage of the game, oh wait, that's a tangent. By this stage of the game, we need to have these things memorized. This one is on your sheet. So if the tangent is sine over cosine, then cotangent is cosine over sine. And then sine over 1 and 1 over cosine. All right, is everybody okay right here? Well, then we start canceling. So it's a 1-for-1 canceling. So 1 sine, 1 sine. 1 cosine, 1 cosine. And what am I left with?
Tan over tangent.
What am I left with?
Just
Sine over cosine is tangent, isn't it? So the answer is just tangent, sine over cosine. This is all that's left. Okay. All right, now, the other problem, so you got one that looks like this. Now the other problem, you're going to use your Pythagorean identities for. Okay? So tell me about 1 minus cosine squared. What's 1? That's sine squared. Squared, remember, they got to be squared. So the paper says this. That equation can be written other ways. I can move the sine squared to the other side. I can move the cosine squared to the other side. All those are the same equation, just things move from side to side. So when I see 1 minus cosine squared, that's equal to sine squared. And you can change those to x's if you want. So I have sine squared over sine, which is just sine.
How do you know when to do that rather than doing like difference of squares?
Well, you can always do that. If you have something like that, you can do the difference of squares. But think about then what that leaves you with. 1 minus cosine, 1 plus cosine over sine. Remember, your objective is to cancel. And you're going to cancel? Yeah. So I want you to think about factoring, but you're not always going to factor because it's not always helpful.
Okay.
Does that make sense?
Yep, thank you.
All right, let's look at the second practice quiz. And again, feel free to change the thetas to x's. All right, now take a look at this. Do you see 1 plus tangent squared anywhere on your pink sheet?
Yes.
And in fact, what is 1 plus tangent squared?
Secant squared.
Secant squared. It's right there. So this is secant squared. So we have secant over secant squared, which is 1 over secant. Right? We can cancel one of them out. And what's 1 over secant? Cosine. Remember, secant is 1 over cosine, so cosine is 1 over secant. They are reciprocals of each other. Okay? All right, what about this guy? Well, I don't change my cosines. I don't change my sines. But what do I do with my secant? 1 over cosine. And what do I do with my tangent? Sine over cosine. Now remember, it's a 1-for-1 canceling. So 1 cosine on the top, 1 cosine on the bottom will cancel. Well, don't I have 2 cosines on the bottom to cancel with those guys? Do the sines cancel? No, because they're both on top. So the answer is sine squared. All right, one more. Okay, take a second, see how far you can get with this first one. Okay, what do we do with sine squared? In this problem, nothing. We leave it as sine squared over 1. Because in this problem, aren't we changing everything into its individual fraction? And then hoping things will cancel? So what do we do with secant? 1 over cosine. And it'll be squared because that's squared. What do we do with cosecant? 1 over sine. And cotangent. Cosine over sine. Remember, the sheet you get for your quiz and test is going to look just like this, okay? So written up here, I tell you tangent is sine over cosine. And you know cotangent is the reciprocal. So that's why it's cosine over sine. All right, so it looks like I've got 2 sines and 2 sines again. 1 cosine, canceling with 1 down here. So what's left? 1 over cosine, which we all know is secant. Who got that all by yourself? Raise your hand. 2 people is all? Okay. Does anybody have a question then? Where did we go wrong?
I would have got it. I just didn't used to do it like that or something.
Okay. All right. Now, what about this last one here? This one looks a little weird. First of all, that's a cube, so don't be looking at your pink sheet, because your pink sheet, everything is just squared. Okay.
Factor out a
Oh, can we factor out a sine? We absolutely can factor out a sine. And if we do that, what will we have left? If we take out the sine, we'll have 1. Oh my gosh, 1 minus sine squared. What is 1 minus sine squared? I had it written here, but I erased it. 1 minus sine squared is cosine squared. So sine times cosine squared over cosine, this right here is cosine squared. Now what happens? We can cancel out a cosine, 1. So what is our answer? Sine on that same, in that same packet, if you're working in the packet, that second page, it says extra practice 5.1. There are a few problems. I had to do this on a separate sheet of paper yesterday, remember? We were working these out on notebook paper. And there were a few we didn't get to. So this is 15. And 16. And 17. So you got 15 and 16 up here. All right, and remember, you have a pink sheet. Okay? So what do you notice about that? You know anything about 1 plus tangent squared? 1 plus tangent squared is secant squared. How about 1 plus cotangent squared? Cosecant squared? You guys, you can't be confused by that. These are on the paper. Now, I recommend that you look at this problem and say, okay, it's secant squared divided by cosecant squared. Because what am I eventually going to be doing? Keep, change, flip. So, what fraction is secant squared? 1 over cosine squared. And cosecant squared is 1 over sine squared. So we have 1 over cosine squared divided by 1 over sine squared. So 1 over cosine squared times sine squared over 1. Well, nothing cancels. What am I left with? Sine squared over cosine squared, which is tangent squared. Okay, did everybody follow along those steps? And what's going through our minds is, I have to be able to do this on my own. Okay, look at the next one. This is number 16. What occurs to you when you see number 16? 1 minus cosine squared. That sounds familiar. What's 1 minus cosine squared? Sine squared? Now, Wyatt, it's also the difference of squares, but the bottom is not, so I'm not going to factor it. It does factor, but I'm not going to do it. Now, this is a little tricky. The bottom is nothing. This is actually as far as we can go with this problem. Because when you look at the Pythagorean identities, all of them, aren't they all pluses? Look in your box. Isn't everything positive in those boxes? So when you start moving things around, like moving a sine squared over here or something, don't they have to be negative? If you're moving them in the equation, aren't they going to have to be negative? Here, nothing's negative. So this did not come from here. Does everybody understand that? So we're done. That's it. That's kind of a tricky one because it's finished right there. You won't have one like that on your quiz. Number 17. What in the world are we going to do with this? First of all, the top is a cube. Do not be looking at your pink sheet. What about the bottom though? What's 1 minus cosine squared? Sine squared. So now we have sine cubed over sine squared. Guys, do you think it's important, this idea that 1 minus cosine squared is sine squared? Have we used that in like 5 problems today? Yeah, you need to recognize that. Well, what happens now? We have sine cubed over sine squared. It's gonna cancel and just leave us with an extra sign. Looked big and scary, but it wasn't. Okay, we still have 20 and 22. Those are our last ones. 20 and 22. Now, these are all squares. So I can be looking at my box. How about the bottom, folks? What's on the bottom? 1. Isn't the bottom 1? So, okay. Now, what about the top? Do I have an identity that has these 2 in it? Yeah. What does it say? 1 plus tangent squared is secant squared. So what happens in that identity if I move the tangent squared over here? Then it would be secant squared minus tangent squared. And what would that equal? 1. Guess what your numerator is? 1? So what's the answer to the problem? 1. And our last practice problem is number 22. Then we will have done them all on this sheet between yesterday and today. And this one's kind of tricky too. Jack? So 1 minus cosine squared is sine squared. Okay, guys. 1 minus cosine squared is sine squared. And likewise, 1 minus sine squared is cosine squared. Okay, now wait a second. Let's take care of the bottom first. Would everybody agree that the bottom is sine squared? Now be very careful with the top. What is wrong with the top? It's backwards. Isn't it backwards? The rule says 1 minus sine squared. The rule says that because this is the identity. So when I move the sine squared over, it's 1 minus sine squared. So this is kind of what I want, but it's backwards. Anybody know how to handle that? Well, let's go back to our identity. What if I move the 1 over here and the cosine over here? What would it say? It would say sine squared minus 1 equals negative cosine squared. If it's backwards, guys, it's just negative. So this is going to be negative cosine squared. Okay? It's all about manipulating your box. When you flip it. So sine squared minus 1 is the same as negative cosine squared. So that goes on the top. That is sine squared, so that goes on the bottom. What's this? We do negative cotangent squared. That's exactly what it is. It's negative cotangent squared. what you gotta do, you got plenty of practice problems, copy them on another sheet of paper. The practice quizzes especially. Copy those on another sheet of paper and run through those. What we're gonna do now is go back to our notes. I know it's a little schizophrenic here, but nothing all over. Let's go back to our notes. And we are going to solve our first non-right triangle. So we're totally switching gears. Coming back to some applied trigonometry. And let's talk a little bit about just general standard notation. When we talk about solving a triangle, that means we have to find everything we don't already know. So you will be given three things. There'll be different things in every problem, but you'll always be given three things. So in this case, I have been given angle A, I have been given this side, and angle C. Three things. Triangles have 6 parts, 3 angles, 3 sides. When we say solve the triangle, we mean find the rest of it. So we are going to have to find angle B, and in triangle land, we use capital letters for the angles. So angle A, angle B, angle C. Then we use small letters, lowercase letters, for the sides. And the way the sides are labeled is important. This side right here is side A, because it is across from angle A. So this side down here would be side C, and this side over here would be angle B. It is important that you label your sides correctly, and it's real easy. The little a is across from big A. So wherever big A is, wherever angle A is, little a is across from it. So if I had a different triangle and this was A, then this would be side A. Got it? Okay. So our job in this problem is to find angle B, and then side B and side C. So when we say solve a triangle, that's what we mean. Find the things that you don't know. Okay, now one of those is incredibly simple. Can't we find angle B really easily? Boys and girls, what do the angles of a triangle add up to? 180. So I have a 38 and a 70. So the missing one must be 72. Would you agree with me? Now, in the last unit on the test you just took, we do triangles all the time. Remember the squirrel in the tree? And you found stuff. You found how tall the tree was, but you were using SOHCAHTOA. And why were you using SOHCAHTOA? Because we had a hypotenuse. We had a right triangle. Do we have a right triangle? No. So no more SOHCAHTOA. SOHCAHTOA only works if you have a 90-degree angle. Otherwise, you have no hypotenuse, no SOHCAHTOA. So what are we going to do? Well, luckily, we have this beautiful thing called the law of sines. And the law of sines is everybody's favorite because it's so easy. It's called the law of sines because it involves the signs. So the law simply says if you take the sine of angle A over side A, that will be the same. That will equal the sine of angle B over B and the sine of angle C over C. So I'm going to come over here and I'm going to look at my problem. This pair I have, do you see that? I have angle A and side A. So I'm going to start by saying sine 38 over 16. Because I have that match. Now, do I have this match? No, of course I don't. I'm only going to have one match. But what do I have? Don't I have sine 72? So I'm going to say equals sine 72 over B. So the sine of 38 over 16 equals the sine of 72 over B. Now, don't worry about this one. We'll come to that one soon enough. We can only do 2 at a time. Okay, the law has 3, but you can only do 2 at a time. So what do we do with a problem like this? It's called a proportion. How do you solve a proportion? Claudia's, this vacation's going like this, right? She's gonna cross multiply. So, B sine 38, that's a B, equals 16 sine 72. And then what do I need to do? Divide by sine 38. And isn't that going to give me B? So let's get our calculators out. Go to mode just to make sure. You're probably in degrees, but I want to make sure you're in degrees. Make sure you're in degrees. And then 16 sine 72, close the parentheses. When you type sine, it's automatically going to put parentheses here. Close it. Divide it by sine 38. Did you get, for side B, did you get 24.72? It's just like when we did logarithms. You have to close that parentheses before you do your division. All right. What am I going to use? Now I have 2 sides. Now I know B is 24.72. So now I have 2 sides. Can I do the Pythagorean theorem like I did in the last unit?
No.
Why not? No right triangle, right? So I'm going to go back and I'm going to do my law of sines again. Only this time, I'm going to say sine 38 over 16. I'm starting with the pair I know, which is 38 and 16. And what am I going to set it equal to this time? Sine 70 over C. Is the order that I do, like I did B and now I'm doing C, could I have done C first and then done B? Yeah, it doesn't make any difference what order you do them. You have to do them both, but the order doesn't matter. Okay, so what do I do here?
16.
So C sine 38 equals 16 sine 70. Just cross multiply. And then divide by sine 38. And that's going to be C. Type that in. Let's see if we can get the right answer. Wow, what'd you get for that one? 24.72. 4-2? Why do you think those answers that we got were so close? They weren't the same, but they were really close. Anybody have an idea why that was? Because the angles are close. The angles were close. If the angles were the same, the sides would be exactly the same. The closer the angles are to each other, the closer the sides are going to be. And the triangle is solved. Done. That was easy, wasn't it? Okay, well, we don't have time to do another one, so we'll stop there. Our next class, we have our quiz. And we'll continue with this conversation about the law of sines.